A Portland Community College Mathematics Telecourse. A course in arithmetic review. Produced at Portland Community College. Recall that in math, the use of a letter is frequently utilized to simply stand for a missing number. A symbolic statement like this simply reads as the phrase, some number, represented by m here, divided by 3. See, each mark in math is simply a language statement. So the secret to much of math is simply learning to read it. Some number divided by 3. This statement, on the other hand, reads 3 divided by some number here called k. And this one reads 3 times, usually between a constant and a variable. The times is not written, but it's understood there. 3 times some number here called a. In all cases, the letter, which we call variables in math, simply stands for the phrase some number. Really, it's that simple. Note here we have one fraction separated from another fraction by an equal. That, recall, is a proportion. Now our objective here is to simply read this, remembering that the variable simply says some number, and this says divided by. So reading this, 6 divided by some number is either 3/4, or you could read 3 divided by 4. So saying it quickly, 6 divided by some number is 3/4. As you continue in math, learn to simply look at every mark as you would a page of written words and read every mark. Now we wish to define what we mean by solving a proportion. Note here is a number here we don't know. It says 6 divided by some number is 3/4. Now if that number were 5, this is a false statement. Asking what number could replace the variable and make this true is what we mean by solving the proportion. Well, by looking at this, you can probably just tell that if you replace the r by 8, this would be equal to 3/4 if I reduced it. So you get the idea that r is 8 to make it true. But now notice something else about this, because this was nice. We could just look at it and see it. But what if we can't look at it and just see what will make it true? Well, remember we said on the previous lesson that this cross product must be equal to that cross product. Now let's say that. This cross product, that is 24, must be equal to, let's say it, this cross product, which is 3 times some number. Let's say it. Obviously I can't multiply. But notice, this is an equation we've been working with now for 2 or 3 chapters. To undo multiplication of the variable, I divide both sides, and see 24 divided by 3 is 8, and 8 was our answer. We're going to focus in on that process. See, as it gets messier, it's not quite so obvious. We can still read it. 8 divided by 20 is 21/28. But now, our statement from the previous tape says that this cross product, which is x some number times 28, which I can certainly write even though I can't do it, is equal to this cross product, which I also will write 21 times 20 without doing it. But now remember, on our getting ready for algebra reviews, you can undo this multiplication by dividing, but I must divide both sides. This undoes this, which says now x is that, which is nothing but arithmetic. Now notice I didn't do this multiplication, and the reason I didn't is there's some cancellation I can do, and it's easier to do the cancellation before the multiplication. Notice 7 goes into here 3, 7 goes into here 4, but then 4 goes into there once, 4 goes into there 5, so I'm left with 3 times 5, which is 15, over 1. So we're saying x, which is now identified as 15, 15 divided by 20 is 21/28, and that is the fact. Let's summarize what we've just done. Now, to solve the proportion, simply set the two cross products equal to each other, then divide both sides of the equation by the multiplier of the unknown. We've known that already, but now let's concentrate on it, so now we can do it almost without thinking. Now, the first rule says to set the two cross products equal to each other. To many beginning students, it's this step right here that they will forget, and that will hurt them. This cross product is 1830. This cross product, since I can't multiply, I simply show it. 26.5 times some number called p. Then the second stage, divide both sides of the equation, which is why I needed that, by the multiplier of the unknown. So here's the unknown. This is its multiplier. So I divide both sides by the multiplier of the unknown. And now, of course, you can see why, because on this side they cancel, leaving me just p, which is what I'm after. And the other side tells me what to do. It says 1830 divided by 26.5. And if we do that either by hand or on calculator, we get 69.58, etc., etc., etc. But I didn't go any further because we want the answer to the nearest tenth. So I went out one place beyond the tenth to find out how to round. This is 5 or more, so I will round up. So my p is 69.6 approximately to the nearest tenth, and I'm done. Again, let's review this. Top times bottom, set equal to bottom times top. Don't forget the set equal to. Divide both sides by the multiplier of the unknown. Cancel, which isolates the unknown. Finish the arithmetic on the other side. You're done. That simple. One of the simplest algebraic equations you'll ever encounter. Let's do another one very quickly to work for smoothness. Top times bottom. 18 times r. Set equal to. Don't forget it. Bottom times top. 26 times 27. Either do it or let it sit to see if you can get cancellation on the next step. Divide both sides by the multiplier of the unknown. There's the unknown, there's this multiplier. Divide both sides by it. Cancel here, follow through. R is 9 goes into here 3, 9 goes into there 2, 9 goes into here 3, 2 goes into here once, 2 goes into here 13, 3 times 13 is 39. So that says that 1826 is the same thing as 27/39, and it is. Top times bottom, set equal to. Bottom times top. Divided both sides by the multiplier of the unknown. And see, sometimes the unknown is over here, so you'll divide by this. Sometimes the unknown will be on the other side. So wherever that unknown is, divide both sides by its multiplier. Now, if your proportion are messy fractions like this, you'll do exactly the same thing. You just have to be prepared to work with messy fractions. But the rule still stands, top times bottom. Okay, this will be 3/2 times 13/4 set equal to. Now, generally when I work them, I don't do the multiplication until I'm all done and do it all at once. Top times bottom. I had to show that as improper fractions. Set equal to. Bottom times top. So in this case, as an improper fraction, that's 6/8 times k. But now remember, we're going to divide both sides by the multiplier of the unknown, which is now over here. So if I divide this side by 8/3, I will undo this. But now I must divide this side by 8/3 as well. I'll show it here, but in fact you won't. Divide by 8/3. But remember, division is times the reciprocal of the divisor. And I'll leave everything else alone. Now, because I'm multiplying, I can check to see if there's any cancellations first. In this case, there isn't any. So multiplying all the tops, 3 times 3 is 9, times 13 is 117. 2 times 4 is 8, times 8 is 64. So my k is 117/64. And of course you might wish to express that as a mixed number, depending what you're going to use it for. And if you did, it would be 1 and 53/64. Again, it was messy, but the procedure never varied from our previous problems. Top times bottom, set equal to, bottom times top, divide both sides by the multiplier of the unknown, do the arithmetic, you're done. Now it will happen that most story problems, like those 3 we saw at the beginning of the last lesson, will translate to simple proportions. And what we hope that you'll find in this lesson, they're easy to solve. The next lesson will focus on that business of translation. This lesson upon the business of solving proportions. In practice, many proportions that you must solve in science or industry in fact involve fairly messy decimals or fractions. And of course, in that case, it's appropriate, in fact desirable, that you use a calculator. In the textbook that goes with these tape lessons, the problems are simple enough that you can do it by hand without a calculator. But for a few problems, let's work with the calculator to show you some patterns that exist within here that you might not have seen yet that will allow the calculator to be much simpler. Let's say we have this particular proportion. We'd like to solve for the value of y accurate to the nearest hundredth. To begin with, it's better to realize this when working a messy problem. Often, your work will be easier if you only show what is to be done, but await until the very end to do it. Let's follow this advice on this problem and see what happens. Repeating our steps, top times bottom. Well, that's 59.89 times 69.27. And see, just as we've been doing for several chapters now, to show multiplication, we just put the numbers in parentheses and shove them next to each other. but always be aware that there is a multiplication here, whether it's written or not. So top times bottom set equal to bottom times top. M times 40.35. See, I showed what I was going to do, but I didn't do it. Now my next step is to divide both sides by the multiplier of the unknown. There's the unknown, here's its multiplier. So if I divide both sides by this, and of course the reason for that is that division is undoing multiplication, so this division undoes this multiplication, isolating the m, which means to solve the proportion or solve the equation. Now see, this is saying m is this, and this is telling me what to do. This times this divided by this. So now I can use my calculator, can't I? So 59.89 times 69.27. Now divide by 40.35 equals, and the problem states that we wanted it to the nearest hundredth, so we can see on my calculator it's 102.8. And look at the hundredth. The one just before it is 4 or less, so I leave that alone. So there's my answer to the nearest hundredth. Now note, I did this times this divided by this. Please note, had I done it in any other order, let's say 59.89. Now let's do the division before the multiplication. So divided by 40.35. Now times 69.27 equals, I get the same number. So I had a choice here. This times this divided by this, or this divided by this times that, or if I wish, this divided by this times that. I'll always get the same results. So that gives you a little bit of freedom of how you're doing it. Plus the fact, if I were doing this first and wrote it down, I have to work, write down, work, write down. So it's much easier if you just save all of your work and do it all at once at the last step. There happens to be a higher pattern here, which will allow you, if you can see that pattern, to go from this problem right straight to the answer and bypass all of this. So let's put this problem aside. We're going to come back to it in just a moment. But what I want you to do is to concentrate on the two diagonals. Note there's a diagonal which does not have the variable, and there's another diagonal that does have the variable. Sometimes the variable is on this diagonal, sometimes on this one. In this case, it's on this diagonal right here. But again, note at the next problem, two diagonals, one without the variable, one with the variable. Please note that. Let's do a second problem. Again, noting this advice that we only show the work and wait until the very end to do it. So we would take this top times this bottom. Now note that we have a diagonal. The down diagonal has the variable, whereas the problem we just finished, it was the up diagonal that had the variable. Do you see the difference? Up here, down here. So the down diagonal, which is 104.2 times b, set equal to the up diagonal, which is 79.8 times now 34.2.7. Now we divide both sides by the multiplier of the unknown. In this particular case, the unknown is here, and here's its multiplier. So I'll divide by it, both sides. Now note, in this case, the number I'm dividing from is over here. In the last case, the number I'm dividing by was over here. So we're dividing by the multiplier of the unknown wherever it is. And of course that's isolated the variable, which is what we mean by solving it. Now we just read the other side and it's telling us what to do. And we can do that all at once. So 79.8, and if I wish, divide by 104.2, now times 342.7, then the equal, and then looking at my calculator, round off to as much as is requested. So I have 262 point, here's 4, and the digit just to its right, it's 5 or more, so that rounds that up to 5. So I have the approximate answer to the nearest tenth. And for all practical purposes, the data itself was only given to us to the nearest tenth too. So it's fitting that our answer only has as much accuracy as what was given to us. Now, if you look at this problem and compare it with the last, you should see a pattern. We're multiplying by two numbers and dividing by a third. Notice the two numbers that we multiplied by fell on the diagonal without the letter. Same with our previous problem. The two numbers we multiplied fell on the diagonal without the letter. In this case, the down diagonal. In this case, the up diagonal. Then in both cases, when we divided both sides, we divided by the number that came off of the diagonal with the letter. So here's a diagonal with the letter. This is the number that came off of that diagonal, and it's the number I divided by. So if you wish, you could generalize. You can say when you have a proportion, you're always going to multiply the two numbers on the diagonal without the letter. Then you're going to divide by the number on the diagonal with the variable. Did you get that? If you did, that will really make a lot of work very, very fast. Watch this. Let's utilize that pattern and see if we can do this entire problem on nothing but the calculator. We said to note that you have two diagonals. Whether it's down or up has nothing to do with it. The only question is, which of these two does not have the variable? These two. Then it's those two you're going to multiply by. So on the calculator, I will take the 0.035 times 1.972, and then, without touching the calculator just yet, I'm going to divide by the number that lies on the diagonal with the letter. So I hit divide, 0.148 equals, and I'm done, and I didn't write anything down. And I want the answer to the nearest thousandth, so this tells me that R is 0.46. Look at the thousandths. The digit just next to it is 3, which is 4 or less, so I round that down, and there. I have my answer without even touching paper except to write the answer down. Isn't that neat? Let's try another one. Again, you look for the diagonal that doesn't have the letter. There it is, the up diagonal. You multiply those two. 796 times 502. Then the other diagonal that does have the letter, you're going to divide by its multiplier, its number. So divide by 258, then equal, and now we can just jump right to the solution, which is 1548. And look at the digit just before the whole number, which is where they want us to round, which is 0.8, so we round up. Now this is so fast that the easiest way to check such a problem, because we can accidentally touch the wrong key, is simply clear it, back off, and do it once again. So 796 times 502 divide by 258 equals, and sure enough, the same results. So pretty soon you can solve proportion problems actually as fast as you can punch calculators, and that is really nice. However, don't get the feeling that therefore everything should be done with calculators because it's so fast. There is a category of problems where you will need it to do it by hand. Let me give you an example. You see, here's a problem using mixed numbers, that is fractions, and most calculators won't work fractions. By the way, this is one of the few that will. But let's do this problem without the calculator. However, the technique is exactly the same. Since we're multiplying and dividing with mixed numbers, we know from our fractions chapter that we need to change them all to improper fractions. So let's do that right now. This would be 5 halves. This should be 15/16 and this would be 12/15. Now all of this should be very automatic to you by now, so let's go back and double check our arithmetic. 4 5 halves, 15/16, 12/15, and it should be just that fast. We know from our shortcut that we can go right straight to the solution. That we have two diagonals. We're going to multiply the diagonals that don't have the variable. So we're going to take 5 halves times 16/3, and we're going to divide by the number on the diagonal with the variable. And of course, when you're dividing by a fraction, you invert and multiply. And since we're only multiplying now, always when you're multiplying fractions, look for cancellations first. So 5 goes into here once, into here 3. 2 goes into here once, into here twice. And that's all I can do. So I have 2 times 16 is 32. 3 times 3 is 9. So I have my reduced fractional part of my answer. But we also want it as a mixed number. So 9 goes into 32 3 times. That's 27, which leaves a remainder of 5/9. So here I have it. Do you see the extreme advantage of waiting to do your arithmetic until the very last step, even without a calculator, and also seeing this shortcut and simply writing down what you're going to do and leave it till later to actually do it? That will save you a lot of time in the next few lessons. So please remember this. This is your host, Bob Fennell. We'll see you at the next very, very important lesson.